My name is Matt Leevy, and I am the Director of Biological Imaging here at the University of Notre Dame. In the past 10 to 15 years, we've seen a dramatic amount of growth within the preclinical imaging space. We've seen a lot of the clinical modalities become adapted for use on the preclinical side, and those would include PET, SPECT, CT, MRI, ultrasound. But we've also seen a number of modalities created on the preclinical side, and those would include luminescence, fluorescence, perhaps optoacoustics as well. So first I'd like to tell you about the Albira PET SPECT CT. This has been a critical acquisition for the core facility here at the University of Notre Dame because it truly galvanized our facility and gave us access to critical application areas that we previously could not reach. For example, on my Albira PET SPECT CT, I have faculty, graduate students, postdocs, undergraduates, and even high school students using this equipment independently to execute their own research projects. So first, let's talk about X-ray CT. This is an anatomical modality that allows us to pursue applications in, say, measurement of adipose tissue in animals, looking at lung tumor burden, looking at nanoparticles and their biodistribution. So next, let's talk about positron emission tomography, or PET. At Notre Dame, we're primarily focused on developing new probes for infection and apoptosis and converting those into viable PET probes. So the final modality on the Albira is going to be single photon emission computed tomography, or SPECT. Now at Notre Dame, we primarily use SPECT to do functional imaging, where we're looking at the perfusion of different probes through either lung tissue or kidney tissue. Now let's talk about the Xtreme. This is an awesome imaging platform that gives you 4 modalities within one instrument: planar high-resolution X-ray, whole animal fluorescence, luminescence, and radioisotopic imaging. So this gives us range to a number of application areas, particularly within oncology, neuroscience, and probe development. And we're very excited to have that at Notre Dame as well. When we have one platform that gives us 4 tools, that's 4 tools in the toolbox for all of the users for our core facility, and that's something that makes me very happy. Next, I want to tell you about the ICON MR system. Now this is a unique MRI platform because it incorporates rare earth magnets. This means that we don't need to have a special room to house the equipment, for one. And for 2, it means that we don't use supercooled magnets, so there's no possibility of us quenching this instrument. So we've had the MR for just a couple months, and I have never seen a more rapid uptake of a piece of equipment in my facility than this. We have had folks coming out of the woodwork to do stroke imaging, tumor MET imaging in the brain, tumor MET imaging in the IP area, in addition to all the other multimodal studies that we're pursuing as we develop the technology. And we're very happy to have it within the In-Vivo facility at Notre Dame. I think the barriers to utilizing all of this high-end imaging equipment have been dramatically reduced and are continuing to be reduced. More researchers will be able to make use of this equipment, and furthermore, we'll be able to cite more of this equipment at universities that are not primarily affiliated with medical institutions. So we're going to see the imaging community continue to grow, and as it grows, we're going to see an increase in the use of multimodal strategies and a range of experimental models.